At 12:07 p.m., a delivery rider stops at a red light in Shenzhen. The lunch he is carrying is still 3 crowded intersections away. Above him, another lunch has already left the restaurant. It hangs beneath a small yellow drone in a sealed red box. Cars wait below. The drone does not. It crosses a park, a canal, and a 6-lane road in a nearly straight line. Less than 5 minutes later, it descends toward a small landing station. The customer sees a quick delivery, but the drone is revealing something much larger. It is not wandering through open sky. It is following an invisible lane. That lane has no asphalt. It is built from coordinates, radio signals, permissions, and landing pads. As more aircraft enter the air, empty sky becomes infrastructure. And China is trying to build that infrastructure before the traffic fully arrives. This is the beginning of a second transport system above the first one, a drone highway over the city. To understand it, follow the lunch back to the restaurant. A worker seals the order inside a lightweight cargo box. The box is weighed before it ever reaches the aircraft. Too heavy, and the flight changes. Too light, and wind can still move it. A robotic arm locks the box beneath the drone. The system checks the battery, then the weather, then the route, then whether another aircraft has already been given the same piece of sky. The drone waits for a slot. Only then does it lift vertically from the station. It does not choose the shortest path by itself. It joins a pre-planned corridor. It stays inside a narrow, 3-dimensional tube. Its position is monitored while it moves. Its identity travels with it. If the wind becomes unsafe, the trip may slow, divert, or return. At the destination, the drone lands on another approved pad. The box moves into a locker or into human hands. The last few meters may still happen on foot. So drone delivery is not simply flying over traffic. It is choreography. Every smooth flight depends on thousands of invisible yes or no decisions. The drone looks autonomous because the system around it is doing so much work. Shenzhen is an unusually good place to test that system. It is dense, wealthy, technologically ambitious, and full of short, urgent trips. It is also divided by bays, hills, parks, rivers, and crowded roads. A ground vehicle may have to follow the shape of the city. A drone can cross the shape. By the end of 2025, Shenzhen said its cargo drones had flown more than 1 million trips during the year. The city had opened hundreds of low-altitude logistics routes. It had also built more than 1,200 takeoff and landing points. From above, that begins to look like a network. But a route count is not the same thing as open sky. Every line is permission. Every landing point needs space, power, maintenance, and someone responsible for it. Every route also needs enough demand to fly regularly. Otherwise, the futuristic aircraft becomes an expensive detour. The first question is not whether the drone can fly. The first question is whether the trip makes economic sense. Does it save enough time? Can it carry enough weight? Can it operate often enough? Can the package transfer without adding another long wait? If the answer is no, the road wins. Shenzhen has one major advantage. The factories that make drones, batteries, sensors, radios, and replacement parts are close together. A broken aircraft can be repaired inside the same industrial ecosystem that produced it. That makes experimentation cheaper. It also turns the city into a showroom for an industry it already manufactures. Beijing now describes the larger vision as the low-altitude economy. The term generally covers activities centered on aircraft operating in airspace usually below 1,000 meters. That includes delivery drones, inspection drones, agricultural drones, emergency aircraft, helicopters, and electric vertical takeoff vehicles designed to carry people. The phrase sounds like a promise of flying cars. But most useful low-altitude work is much less glamorous. A blood sample crossing a city before traffic can delay it. A drone inspecting a power line without sending a worker up a tower. Emergency supplies crossing a flooded road. A meal reaching a park without a motorcycle circling for 20 minutes. The future often arrives disguised as a boring delivery. China has promoted the sector as a national emerging industry, and the number of aircraft is already large enough to make management unavoidable. By the end of 2025, China had more than 3.2 million registered drones. They logged more than 45 million flight hours during the year. At that scale, regulators cannot depend on pilots simply looking out of windows. Every aircraft has to become visible to a system. Registration answers who owns it. Operational identification answers which aircraft is moving. Flight data reporting answers where it is and what it is doing. Route approval answers where it is allowed to go. Local service stations help coordinate what is happening in the air nearby. China's national drone rules took effect in 2024. A unified management platform began handling registration and operational services. New mandatory standards took effect in 2026. They strengthened real name activation and the active transmission of identity, position, speed, and status. Aviation sounds romantic. The actual highway is a database. The aircraft carries the parcel. The network carries the aircraft's identity. If either one disappears, the system cannot scale safely. The low-altitude economy is therefore also an economy of machine visibility. The sky may look empty to a person standing below. To the network, it is filling with moving data. And data alone is not enough. A drone route needs an accurate three-dimensional map. Buildings matter differently in the air than roads do on the ground. A construction crane can appear where yesterday there was empty space. Wind accelerates between towers. Glass can confuse reflections and signals. Birds do not file flight plans. Emergency helicopters cannot wait for a food order. Temporary security zones can close a corridor without moving a single building. Weather at rooftop height can differ from weather on the street. A battery reserve must include the possibility of a detour. A landing pad has to remain clear at exactly the right moment. A package that shifts inside its box can change the aircraft's balance. Even a loose plastic bag can become an airborne obstacle. This is why the sky cannot be treated as one giant empty room. It has to be treated as an intersection. And intersections require traffic lights. For drones, those lights may be software, time slots, altitude layers, geofences, priority rules, and an emergency override that can clear the route immediately. Then comes the problem people hear before they understand it. Noise. One small drone sounds minor. Hundreds of them can become a new layer of urban texture. Privacy creates another argument. The operator may see a navigation sensor. A resident may see a camera above the balcony. The city may see useful traffic data. An insurer may see a moving risk. Police may see an aircraft that must identify itself. The same machine means something different to everyone beneath it. Weather remains the least negotiable participant. Rain can reduce reliability. Heat can weaken batteries. Wind can reduce range or payload. Turbulence can form around dense buildings. Every aerial promise therefore needs a ground-based fallback. Usually that fallback is still a courier on a road. The drone highway does not replace the streets. It decides which trips are valuable enough to leave them. Early systems are built from simple point-to-point routes. A restaurant to a park, a hospital to a laboratory, a warehouse to an island. But a citywide network needs hubs that connect those routes. One route is a bridge. Many connected routes become a web. Smaller transfer stations allow more shops to join that web. More landing points shorten the difficult last mile. More volume can lower the cost of each flight. But more traffic also demands tighter control. The network effect and the regulatory burden grow together. Every new route makes the next route easier to justify, and the sky harder to manage casually. Most headlines still focus on air taxis. Cargo drones are doing the more important early teaching. A package does not panic. It does not need a comfortable seat. It can follow a fixed route every day. And a failed delivery is not the same as a failed passenger flight. The mundane drone is teaching the city how to manage the glamorous future. At 12:12, the lunch reaches the landing station. The customer sees 5 minutes. The first flying city may arrive not with a flying car, but one lunch at a time.